And I just uploaded my slides also into the Zoom chat. So I hope you can see that. And yeah, welcome to the co-host. I still to start video. Start my video. Okay. Yeah. So welcome to the technology track of this conference. This is the first session now. I am Markus Sabadello from Danube Tech. We are a small company working on DID and SSI technologies in Vienna, in Austria. It's about 3 a.m. right now, but that's fine. I'm very excited to be part of this conference. And myself, I've been working on DIDs and related technologies for a pretty long time, and have contributed to a number of organizations and community efforts in this space, like World Wide Web Consortium, where I've been working on a DID standard, and DIF, Decentralized Identity Foundation, and some other initiatives like EBSI, the European Blockchain Service Infrastructure, ID Union, Sovereign, and other projects. And my topic here, as the first session in the technology track, is trends in the DID technology development and the status. So this is going to be a bit more technical than other sessions maybe. What I tried to do was to compile and collect a number of updates and some recent topics and recent new ideas and developments in these different areas, right? So when we talk about DID and self-sovereign identity, there are a lot of technical building blocks, a lot of technical specifications and data models and protocols, and a lot of different pieces, the different building blocks. For example, of course, DIDs and verifiable credentials and protocols for wallets, but also a lot of other topics. And I definitely don't know everything, right? So this is probably just a sub. Okay, so I will continue. Like I said, there's really a lot of different technology and a lot of different building blocks and developments, and I'm trying to follow a lot of it, but I certainly don't know everything. But for some of these topics here, I prepared some slides with concrete updates or current questions or recent developments. Starting with the first one, DID core. That's a well-known specification in W3C that is now a proposed recommendation, right? And the conference is called the DID conference, right? So everybody knows what DIDs are. They are really the foundation for everything else. This specification has been mostly stable, so there hasn't really been a lot of development or a lot of new updates. There have been some smaller fixes, some smaller changes, just to fix some language or some examples, but otherwise there are not really any big new developments. This is pretty much stable. There has been a bit of a political process where some companies object to the standard, and there's now a process to try to overcome that. But on the technical level, DIDs are pretty stable, I would say. There is another specification called DID resolution. That is not a standard yet. That is a community specification, some people are working on this, so there are some updates happening here. This specification is about standardizing or defining data structures for and protocols for DID resolution. This builds on DIDCOM, on the DIDCOM specification, and it adds some additional functionality and some additional technology about resolving DIDs, and there's a little bit of work happening here. Like I said, around data structures, around the protocol, some new error codes, for example, that are being defined here. There is also, of course, quite a lot of development and movement around DID methods, right? So the DID specification is only useful if we have DID methods, and there are over 100 different DID methods right now. So there are more and more all the time. New DID methods are being added. Some of them use blockchain, some of them don't use blockchain. Some of them are self-sovereign, some of them are maybe less self-sovereign and maybe more centralized. So there's a lot of diversity in new DID methods, and as a consequence, what I'm observing, I think, is that there is also a lot of interest in trying to compare different DID methods, different types of DIDs. There has been some work on evaluating and comparing different DID methods. For example, a document where 7 different DID methods are compared and evaluated. There is also a working group at the Trust over IP Foundation, the Utility Foundry working group, which is trying to come up with a list of different DID methods and how they compare to each other. So if applications or services are built for DID use cases or certain DID applications, then there's often the question, which DID method should you use? Right, in the previous session, there was some discussion about legal aspects and GDPR. Well, those questions also depend on the technology where DIDs are stored and how they are managed, and that's why different types of DIDs exist. So yeah, at the moment, I think there are over 120 DID methods. Here are some new ones that are right now being developed. For example, there's also a DID method that is just using DNS for DIDs. One relatively new DID method that's very interesting, that's receiving a lot of attention, is this one, DID-INDI, which basically replaces an earlier DID method called DID-SOLVE. This is being used in the Hyperledger INDI community, right? Hyperledger INDI was one of the first pioneer technologies for implementing DIDs, and there are quite a lot of applications and also production use cases in the world that build on, that use this Hyperledger INDI technology, and there's a new DID method now, DID-INDI, that is being defined, which has a number of advantages over the previous DID method, DID-SOLVE. This is especially interesting because it has better support for DID documents. It has full support for the DID standard for storing metadata inside a document, and also it has support for multiple networks. So you can see, for example, a DID like this, which identifies exactly on which network the DID is stored, right? And as I said, in different countries, there are different DID networks based on the Hyperledger Indy technology, for example, Sovereign or ID Union in Germany or Indicio or some others. And with these new DID methods, it's possible to identify exactly on which network a certain DID can be found. So this enables cross-network interoperability and what some people call a network of networks. So this is receiving quite a bit of attention in the community. There are some smaller discussions in related to DID methods. So there's a registry, right? The DIDSpec registries. That's where DID methods are registered. There are some discussions right now about policies. So, for example, who can register a new DID method? Should DID methods only be registered if they are completely compliant and mature and well specified? Or is it also possible to register DID methods that are still work in progress or still provisional? And who should have the right to change DID methods, or what policies there should be for naming DID methods, right? There's a DID method called DID ID or DID carry. There have been some discussions just about the policy of how they can be registered. But in general, I think this is all working very well. I think on the DID layer, everything is relatively stable and mature. Moving on to verifiable credentials, some updates what's happening here. This is quite interesting. Verifiable credentials have been a W3C standard or W3C recommendation for a pretty long time, actually more than 2 years. But since then, very recently, there has been an update to the standard. So there is now verifiable credentials data model 1.1. You see this has a date now of 3rd of March. So that's in 2 weeks or so. So this will be published very soon. This is a maintenance update, right? So this has no breaking changes. This does not change anything significant, but it improves some smaller aspects, some editorial changes that do not break existing implementations, right? Just some clarifications how, for example, how dates are represented, or if in certain places in the specifications, if URIs or URLs are used. And one interesting addition that I find very helpful in this update is there's a new section on differences between contexts, types, and credential schemas. This is something that often causes a bit of confusion. I can maybe show that here. So here is a new section that is being added, and it explains how these different features, what they mean and how they relate to each other. It explains how type is used to express what type of credential you have. Is it a birth certificate or a driver's license or a vaccination certificate? That's type. And then there is credential schema, which defines the structure of the data in the credential. And then there is add context, which defines the meaning of properties in the credential. So this is one of the sections that's new in this update. Again, it doesn't really change anything, but it adds some additional clarification. At the moment, there's a process to set up a new working group for verifiable credentials data model 2.0. And there is now a charter that is being written. So the charter defines what the working group will actually work on, right? So it defines the objectives and the scope and the content for a new working group, which will then produce verifiable credentials data model 2.0. And this can introduce also some new features and some breaking changes potentially. So this can have some bigger updates. And this will include the verifiable credential data model 2.0, the specification itself, but also a second specification called verifiable credential data integrity, which will standardize how you can add proofs like signatures to a verifiable credential. This was previously called linked data proofs or linked data signatures, and a lot of people actually don't know that this has not been standardized yet. Right, a lot of projects, a lot of implementations use this to put signatures and proofs on a credential, but this is not a standard yet. And so this will be called verifiable credential data integrity and will be standardized in this new working group. This will also standardize some specific types of signatures or specific types of proofs using different cryptographic key types, right? A lot of implementations are already using these types of keys and these types of signatures already, but strictly speaking, they are not standard. So that will be in scope or will be part of this new working group to standardize some of the important missing pieces. There are some technologies that may also be standardized in this new working group, but that's not certain yet. This is a little bit optional. That's on one hand BBS plus signatures, which is receiving a lot of attention. I have a bit more information about that on the next slide. And also this so-called JSON web proofs. I also have more information about this on the next slide, but these are two things that may become standardized in this new working group or maybe not. One objective of the new working group is also to better align and bring together verifiable credentials in these two formats, JSON LD and JWT, JSON Web Token. This has been a subject of many discussions in the DID community. There are basically different credential formats, and some implementations and some projects use this one and some others use this one. And one objective of the new working group here will also be to try to bring them closer together. There are some details, for example, around these properties here. When you include information in a verifiable credential of when was it issued, when does it expire, when does it become valid, and when does it become invalid, there are some small nuanced differences between these data fields, and that has caused some implementation challenges in the community. So one objective is to try to fix some of this. Another objective will also be to have better support for selective disclosure and zero knowledge proofs. which has to do a little bit with this here BBS plus signatures, but we'll talk about that a little bit more on the next slide. And then, so right now the working group does not exist yet, but the charter for the working group is being written, and there are also some open questions. So one question is, for example, also if this new working group should also standardize protocols or create documents called nodes, right? So a node is also an official output document of the working group, and there's a question if this working group should also specify protocols for verifiable credentials or only the data model. And maybe another question for the working group will also be to what extent or whether or not JSON-LD and the add context feature of JSON-LD will be required or not. So there are some open questions on what exactly this working group will do, but it has some very, very useful objectives, I think, especially to standardize some of the pieces that are still missing in the community. Here are some other things that are happening in verifiable credentials. There's actually another working group in W3C that will be started, and there's also a charter that is being written right now. And this proposed working group is called RDF Dataset Canonicalization and Hash Working Group. Strictly speaking, these are proposed working groups, right? The working groups don't exist yet, but there is a proposal to start them. And this working group will also standardize some technical processes for canonicalizing and for hashing RDF data, which is then required for this verifiable credential data integrity. So when we create a signature, when we create a proof on the verifiable credential, then we need to standardize this too. This is also one of the missing pieces that the community has been using for some time, but it hasn't really been standardized. And yeah, some other interesting developments. There is a draft specification also about something called JSON web proofs and JSON proof tokens. So this is a way of doing verifiable credentials and proofs without JSON-LD. So if you are working just with a plain JSON technology, then this is a draft specification to define how you can do especially zero knowledge proofs with just plain JSON. So this is very technical, but it's a little bit similar to how we have JSON web token and JSON web signatures. There's some work happening to do something called JSON proof token and JSON web proofs. And BBS signatures or BBS plus signatures, something I already mentioned. This is getting a lot of attention. It's a quite popular way of signing a verifiable credential in a way that enables selective disclosures, right? So if we have a verifiable credential with 10 attributes, but I only want to present 2 out of these 10 attributes a verifier, then I can do that with this signature mechanism. And like I said, this may also be included in the new working group and standardized. There are some draft specifications. The links, all these links are in my slides. Just a few days ago, I think there's been a new specification to make the cryptographic keys that are required for this, to make this compatible with the JWK, JSON Web Key standard, which I know sounds very technical, but this is also an important step towards better standardizing this. There's quite a lot of activity around it. There's some discussions about privacy and something that's called holder binding. So that means if you use this signature mechanism, if you use this for selective disclosure, then how do you prevent abuse? How do you prevent fraud? How do you make sure that these attributes really belong to the holder who is using them, who is presenting them? And so there's still a bit of discussion, but in general, I think there's quite a lot of support in the community for this. Okay, maybe I will try to not talk about every single technical detail too much. Here's just a list of some other recent developments in the verifiable credentials ecosystem. There's some new ways of checking the status of a verifiable credential. Is it revoked or suspended or still valid? There's some proposal on how a verifiable credential can be refreshed. So if it expires, if the verifiable credential expires, there are ways how you can request a new one, how a new one can be requested and refreshed. There are a lot of new ideas for key types and signature types. For example, to support P256 and P384. These are key types that are very much in use in some ecosystems. And a lot of discussion on these technical details, how keys should be formatted. Some keys are then also considered to be, or some key formats are at some point also considered to be deprecated, meaning not recommended anymore. And there's also work happening on proof types that you can put on a verifiable credential, which are not signatures, so other types of proofs. Moving on, one interesting thing that happened, there has been a report, a security report with a review of the security of verifiable credentials and decentralized identifiers. This was done by a company called SRI International, paid by the US Department of Homeland Security. They made some really interesting recommendations on how decent verifiable credentials can be used. For example, that keys should not be reused, right? You should use keys only for one thing and not reuse them. One interesting recommendation was also about wallets, and this has resulted in a pull request in one wallet specification. And this recommendation basically says that wallets should not have a generic signing capability. So a wallet should not expose an API that allows it to sign anything, but it should be more specialized. A wallet should be able, for example, to sign a verifiable credential, but a wallet should not be able to sign any string or any piece of data that you want. So I could recommend this to look at some security and privacy recommendations. I think I should maybe accelerate a little bit and not spend too much time on everything. This is very interesting. Test suites have always been important in the DID and verifiable credential community. There's to test different implementations and to test how compatible and interoperable they are. There's a test suite for DIDs. There are multiple test suites for verifiable credentials. And recently, just in the last few weeks and months, there have been additional test suites for some of the very specific technologies, for specific key types or specific revocation mechanism, or a test suite for one specific DID method, so implementations can test if they are compliant. Another interesting thing also related to verifiable credentials is a new effort now to standardize anon creds or anonymous credentials. I can also quickly show that. So here is a new specification that is being started right now to standardize a type of verifiable credential known as anon creds, which has been used in communities that use Hyperledger Indy and Sovereign. And in these DID networks, there has always been a strong focus on privacy and selective disclosure. So every time when you use a verifiable credential, it has strong protections for privacy for the holder. And this has never been standardized, right? So this has been used a lot, and it is used also in some production real life systems, but this has never been standardized. So there's a new effort now to standardize that. There has been a little bit of controversial discussion because this is not exactly based on the W3C standard, and there's some community discussion if too much privacy and too much anonymity or pseudonymity can lead to problems, can lead to fraud and abuse. So that's an open discussion, but in general, it is probably a good thing to standardize this technology, since it is already used a lot. And there's also discussion about a new version or next generation of this anonymous credentials 2.0, which may then be more ideally this will then be also completely aligned with W3C verifiable credential data model. So in general, I think one of the trends in the communities is also to really work more and put a stronger focus on these kinds of privacy preserving technologies. Here is one work item that's also quite interesting, the verifiable credential API. So this is a specification for APIs of issuers, holders, and verifiers. This was originally started by some companies in the Silicon Valley Innovation Program by the US Department of Homeland Security. The idea here is that there would be standard APIs for issuing and for verifying credentials, so that software from different vendors or different implementations can be replaced and substituted. There are some new features, some new discussions, weekly meetings also to try to improve this. One recent feature is about something called workflows or exchanges, where you can have multiple steps or a sequence steps that need to be performed when a credential is issued or verified. Another discussion that's happening here right now, if this API, when you use it for verifying, if it should just check a very small set of aspects of the verifiable credential, like for example, should it only check the signature and the expiration date, or should this API also be able to verify and validate many more parts of a verifiable credential? So there's some discussions, some improvements happening to this, but I thought it was also interesting to have a slide about this, since it's being used quite a lot. So I have 2 slides about wallet protocols. So that's one of the big topics, I think. And I should I should really speed up a little bit. That's one of the big topics, how verifiable credentials are actually being exchanged between issuers, verifiers, and holders. One popular protocol for doing that is OpenID Connect. Just recently, there have been 2 new draft specifications for something called SIOP version 2. This means self-issued OpenID provider. This basically makes OpenID Connect compatible with DIDs. I think this is getting a lot of attention in the community. The second draft specification is about OpenID Connect for verifiable presentations. So this makes it possible to transmit verifiable credentials and verifiable presentations over the OpenID Connect protocol, with or without DIDs. So this can be used together with this, or together with DIDs, but it can also be used without DIDs, and I think a lot of projects like this development, because OpenID Connect is a very mature and well-known standard. But then there are also some other ways how wallets can communicate and can interact with an issuer and the verifier, how credentials can be moved between an issuer and a holder and the verifier. There's of course DIDCOM, which is a very innovative protocol that can actually be used for much more than just identity. This is not just for credentials, and there's a lot of innovation happening how for all kinds of transactions or interactions based on DIDs. This is becoming very mature now. There are a lot of different implementations in different languages. Interesting experiments, for example, sending DIDCOM messages through a peer-to-peer network, and some other interesting developments. And then there's also CHAPIT, a credential handler API. That's a browser API, so you can have a wallet inside a web browser. This has recently also had some new features, for example, some support for native wallet applications. From my perspective, this is one of the big open questions still in the DID community, how wallets will communicate with issuers and verifiers, because there are a number of different ways of doing that. In the interest of time, I think I will skip this just very, very briefly. And in DIF, in a decentralized identity foundation, there's also a specification to try to standardize interfaces for creating, updating, and deactivating DIDs in an abstract way. So you can create and update and deactivate DIDs in different DID methods using a generic interface. I'm also listing some things that are happening that go a little bit beyond DIDs, right? Almost everything we do has something to do with DIDs, but there are also interesting initiatives that do not necessarily use DIDs, but are still interesting to follow. Carry is getting a lot of attention. Personally, I actually don't know so much about it, but I know it's a new way of really achieving self-sovereign identity or decentralized identity in a very radical way, without central authorities, without intermediaries. This is a technology where you can always prove that you control a certain key and a certain identifier, and nobody can take that away from you. And there's a whole set of specifications now that are being written. So it's not just one specification, but it's, I don't know, maybe 10 or so, a long list of draft specifications. The intention is to standardize this technology in IETF, and there are some very large and important companies that are already deploying and using this. So it's definitely one of the big trends. And then some of the smaller and lesser known, not so well known things is quite interesting. If you follow some mailing lists like Project VRM, this is a very old mailing list which Doc Searle started, who gave the keynote speech. And there's some very interesting discussion about completely thinking about DIDs in a completely new way, in a very new way. I think I don't have so much time now, but there are concepts, ideas called exclusive self-ownership, zero copy, which means that you basically, that your data is never copied anywhere. So nobody copies your data. You just send your data to a verifier when they need it, but they never store it. And some ideas, there's some ideas where you never share your data, where you just answer questions about your data, right? If somebody wants to know how old you are, then you don't tell them how old you are. You just tell them that you're over 18, for example. So this zero knowledge proof example is being discussed now. So there's some very new and very innovative ideas that are happening. And this is, I'm almost at the end. Here's some places I could recommend for following trends and for staying up to date. There's the DIF newsletter. There's Identisphere, a newsletter with updates from the community. And my final comment, maybe what I think big upcoming topics or technical topics in the community will continue to be wallets on one hand, and also revocation is a big topic where a lot of discussions are happening. How can you revoke a verifiable credential, but at the same time preserve privacy? That's a big technical topic. Connecting SSI to Web3. By that I mean there are some communities and some projects that are working on connecting blockchains, smart contracts, and decentralized autonomous organizations, DAOs, connecting some of these Web3 concepts to SSI, or NFTs, for example, right? Tokens. How can you connect a certain token on a blockchain to SSI? It's very interesting. And last thing I'll mention is just the idea of making it all globally interoperable, right? How can we build DID networks and systems that don't just work in one country or in one use case or in one industry, but how can we make the technologies and the standards so that they work everywhere and they become interoperable, just like the web itself. For example, just the last thing I'll show now. We have recently done some project to try to connect and a DID network or a DID project in the United States, built or supported by the Department of Homeland Security. There's a use case around the permanent resident card, the American Green Card. And here in Europe, we have a DID network, a project called EBSI, European Blockchain Service Infrastructure. And we did an experiment to try and connect that, right? If we can take a verifiable credential that's issued by an American issuing institution, the American government, how can we then verify that by an institution in Europe? And also the other way around. So if you're interested in that, I may maybe copy and paste a blog post around that. And I've probably taken way too long, but I will say thank you now. This is us, DIDCOM. We also have I'm not sure if I'm allowed to promote a product here in this session, but we're also working on a service called DIDCOM for working with DID technologies. And that's it. Thank you. I'm not sure if we have time for questions. Sorry for taking so much time.